Why don't you tell me why you think the Earth is a globe? That might be easier.
No, I maintain that I don't know for sure.
All right, what is your best proof that makes you not know for sure? You have to have something other than
Yeah.
every observation you've ever seen is flat, water lays flat, you've never felt yourself spinning. None of the stars ever change position, even though all the stars are orbiting these other stars and everything's going in their own directions, but no two stars ever change positions, ever.
Yeah.
Besides that, besides that, the Georgia Guidestones had a little tiny hole that pointed towards Polaris for over 40 years, even though we're going 193 million miles from one side of the sun to the other,
Yeah.
traveling 4.5 billion miles a year, never to return to where we were before. It just stayed there.
Yeah. Yeah.
Okay. Every single thing I just said, each one of them alone proves the Earth is stationary and non rotating. So, why do you think the Earth could possibly be a curving globe?
Yeah, I mean, look, I think we're like for flat earthers, where I appreciate is like they point out a lot of the absurdities of science. So science is incredibly absurd. Like for example, even the age of the Earth, they just casually were like, or the age of the universe, they thought it was 14 billion years. They're casually like, we think it's like 30 now. They're just updating it. So I think we're definitely being lied to, and I don't think they know the nature of reality. And for me, I'm kind of like a like I identify as like a non-local consciousness. Like I think consciousness is actually supreme in reality. We're almost like in a shared dream, a bit of a gnostic in a sense. So meaning
Yeah.
like I think what we can see is like a collective dream or illusion. So I think it could be manifested as a ball and it could be manifested as flat, depending on like the dominant narrative of people. Where I think they're where the where I think the general view of the shape of the Earth breaks down is like, yeah, you see these guys with the P900s who see way further than the curve, and they see things they're not supposed to see, and then the people say, oh, it's not possible. Then they show them on the map, yeah, we were seeing like 16 miles, 17 miles, and then they're like, oh, well, it just like bends light around the ball, right? It's like, no, you guys can't explain what's going on there. We see a lot of things like that to me shows that like what their view of what's going on isn't there. But for me, like the flat Earth models don't make any sense to me. So for example, like, all across the world, there's precise times where the sun
Yeah.
rises, and the flat Earth model cannot accurately predict that. They cannot predict, Fiji will have, a sunrise at 5:55, and then, Chile will have it at 6:15,
Why can't the flat Earth predict that?
show me a model where you guys can accurately predict it. Like I've seen what flat earthers say in your model, and no, for sure they don't. Like
So
like
the sky is a perfect clock, right? The sky is supposedly this gravitational mess of planets. Everything's pulling on each other. The sun, a ball of gas in a space vacuum, which is impossible, is holding on to Pluto, which is at a distance which you can't even fathom. But it can't hold on to our moon. It can't affect our moon. It can affect Mercury and Venus, which are closer to it. It can affect Juno and Uranus, but it doesn't affect our moon. So we have all these planetary alignments. Everything goes around. Nothing, everything, everyone just each gravity minds its own darn business, right? And then every single thing is exactly where it's supposed to be. There's a movie called The Mechanical Realm, which is about the Antikythera mechanism, which is found off of Greece, off the island of Antikythera, 2,000-year-old computer, basically, that perfectly predicts eclipses, planets' positions, everything, all based on a flat Earth. So you want a model? There it is. You got to watch the movie, and then you'll know. You can find that movie on my app if you hit the more resources, which is the web
no, but
button.
go back there to your
Movies,
the sun,
movies. Right. Yeah.
because that's what I'm talking
the sun.
about. Now I'm just saying
Yeah.
there, like we know precisely what locations get what like sunrises, right?
Yeah.
And that you cannot with that model, because I've tried to do it. You cannot show me like you cannot predict the precise times of the
Yes, you
sunrise
can.
in each location.
Absolutely, you absolutely you can, because it comes they know exactly where it is in the heliocentric model. All of those tuggings of gravity, it would change constantly. Like there's no way it could ever. You know about the three body problem, right? Do you know what the three body problem is?
Mm-hmm.
The
Well,
three
I've seen
body
the show.
problem is well, no, not that. In a computer, they can get two masses, a sun and a planet, whatever, and have them orbit, and it'll know exactly what it's going to do forever. But if they get three bodies, right?
Okay.
They
Yeah.
get three bodies, and these are three equal bodies. God forbid they were different, and they
Yeah.
put them in a simulation. All of a sudden, the gravity start pulling on each other, and they go into total chaos mode. And
Yeah.
they can never figure out. No one can figure out what it's going to do next. But we have hundreds of bodies in our solar system alone, billions and billions in our galaxy, and somehow none of everything is in perfect order, finer than a Swiss watch.
Mm-hmm.
Right? That is impossible.
Yeah,
But I'm
no,
going to show you. You're
like
talking about
I'm
sunrise and sunset.
yeah, like I'm with you most of the way. Just to be clear, like their explanation about the moon is totally ridiculous. Like the whack theory, where it's like some space rock that came in and then hit.
Yeah.
Like so, I'm with you in a lot of things. It's just like also the seasons. Oh, go ahead.
Yeah. These seasons are good. I'm going to completely dismantle what you just brought up, okay? And then you are going to have to admit, I'm going to hold your feet to the fire when I'm done. You can tell me I'm wrong and tell me why, or you can you can tell me you can stop me and or tell me you're right. So here, this is what I want to show you. Where'd it go? There you go. So I want to show you that. I want to show you this. So this is I think this was July 8th or whatever. This is the Weather Channel. Now, is the Earth a ball in the heliocentric model? Yes. If you have a dark room and a single source light, anybody can do this. Get a big light, a big flashlight, spotlight, whatever, and put it on one side of the room and get a basketball. It will, no matter how you tilt and spin it, it'll only light up exactly half of the ball. It'll only light up exactly half of the ball. Agreed? Right?
Yeah.
Didn't think that through. Right?
Yeah.
But this is lighting up 70% of the ball. And they have to do that because the land masses that are this far over are lit at the same time. So let's take a look at what that looks like, right? Let's take a look. So here is day and night. On this is August 13th. And all of America, South America is in the total light, right? All of this. The only thing that's in the dark is Australia and these islands over here. That's really the only thing. The only land that's in the dark. Okay, this is, forget what map this is. This is time and date showing us where it's light. And you can verify. Somebody in Alaska can talk to somebody over here. And yep, it's light, it's light, it's light, it's light, all at the same time, right? So this is observable reality, right? So now let's take a look. This is the flat Earth map. And I'm going to put the sun right where the sun was at that time during that picture. And we're going to lift it up. We're going to lift it up and see where the light goes. And the light is going to cover exactly these continents.
I see what you're saying.
Just like we're seeing here. So this is matching the flat Earth. Now let's look at the globe. Let's look at the globe. So we're going to take their globe, which is ridiculous. No pilot ever brings a globe into the cockpit. We're going to take their globe. And we're going to take, just like I said, we got a single source light. We got a globe. It's tilted just like it's supposed to be, tilted to the sun. And watch carefully. We got Australia right there, and we're going to put Australia in the dark, just like it was. So Australia's in the dark, and now we're going to go to the other side of the globe, and we're going to see where is America and South America. They're in the dark. They're totally in the dark. So that's not right. So maybe it's wrong on this side. So let's spin the globe. We'll put the light exactly where it was according to the time of date. So we got, California's just in dusk. We got light time right there, so that matches. And then we go back over here, and all of Russia and everything else is in the dark.
Yeah. So wait.
Doesn't work.
Okay, so I see what you're saying. So it's exact 50% when you have the spotlight, so you're replicating the sun. But if you go back, that's the mainstream light map.
This is the.
Where are you getting that?
Map.
Where's that
globe.
come from?
That's the globe from NASA. That's the map.
That's from NASA? Like that's a light map?
No. This is time and date. This is just giving us, this is where it's light.
Yeah.
And this is how they explain it, right? The Weather Channel showed you a 70% lit sphere, impossible. A flat Earth map, which is reality, shows you, hey, light, a single source light can light up these areas and have these areas in the dark.
Yeah.
Okay, it can, it does work, but a globe does not work. Do you understand?
Yeah, I see what you're saying. Yeah, I mean, if NASA's saying that at any given time 70% of the world is lit up, then that's definitely suspicious. But I'm more talking about like,
Wait. Before you, let's stay here for a minute.
yeah,
Observable reality matches measurable reality. Then we look at the globe. It doesn't work on a globe. You have to eliminate one of those. Are you eliminating this one that matches what we observe? Nope. Are you going to eliminate the globe?
yeah.
Yes.
Well, I'm gonna send you what I'm talking about, right? Oh, I lost you on Zoom here. Hang on. I sent it to you, and
what did you send?
just like what I'm talking about, the Zoom maps here. Okay, you're back in the chat there. Oh man.
Okay. Yeah, it's the same thing. Time and date.
Right. Yeah. So that's what I'm talking about. Like, there's like a precise, like to the minute prediction with the globe, the ball of when the sun's gonna come in, and I've never seen a flat earther do that, like to the minute.
You're wrong. So you see that little figure 8 where the sun is? That's called the analemma.
Yeah. I know what that is.
You're familiar with the analemma?
Yeah.
Why is it small in the north and big in the south?
Because the Earth is
fatter on the bottom. Are you listening to Neil deGrasse Tyson? Are you actually going to say that?
No, I'm joking. I know. No, I love how. What did he say again? It was like it's 100 miles fatter.
It's a little chubby on the bottom.
Yeah, whatever.
Yeah, he's like a pear. Okay.
Yeah.
So let's talk about seasons. Okay. So you and I are outside. It's freezing cold, and somebody comes by and says, "Oh, this is you. You're lying on the floor. I think you might be a girl." Okay. And somebody's holding a heat lamp directly over you.
Yeah.
And now you're warm. Yeah. And I say, that's your summer sun. Okay. I say, where's that sun? And you say, it's right up there. It's straight up.
Yeah.
And so I said, where's your sun? You're like, it's right directly over me. It's high in the sky. I'm warm. And then you say, well, where do you see it? I said, well, I see it like at a 40-degree angle. It's really low in the sky for me. And I'm kind of cold. Right? Then 6 months go by, and that person walks over, keeping the sun at the exact same height, and now I see it much higher in the sky, even though it's the same height.
Yeah.
And you see it lower in the sky. I'm warm, you're cold. My summer, your winter. Season, right? Because they tell us it's the tilt of the ball. We're just tilted away from the sun, even though we're 3.5 million miles closer to the sun in our winter in the north. It's colder. Well, that's only 1 or 2 or 3%, whatever. Okay, it's the tilt. If it was the tilt, think this through. What about sunrise in the summer here in Connecticut? At sunrise, when we're 3 million miles farther from the sun than we are in the summer. Than we are in the winter, 3 million miles farther. At sunrise, I can feel the heat. I can take my shirt off. I can get a suntan. I'm warm. It should be freezing cold. I'm farther from the sun, and it couldn't be any more tilted away because the spin is tilt. The tilt is tilt. The spin is tilt, right? But there's the heat. Why? Because the sun is closer. It's closer. The sun is small. It's local. I don't think it's physical. I think it's a projected point of light, just like when you burned ants as a kid with a magnifying glass. You still do that?
I try not to.
Do you?
No.
I try not to. But that little hot point, if you lift the magnifying glass a foot in the air, that point's not gone. It's just in the air. It's just in the air. I think that's how we see the sun. I think we see the sun coming through the firmament. Yeah. Right? Let me show you what I mean by an optical sun, because this will help wrap your mind. Because listen, the globe model makes you stupid because it has, this is it, the sun's a physical gas ball in a space vacuum orbiting, holding on to Pluto and ignoring our moon. It does all that. But that's just the way it is. You just have to accept that. And where's my thing? If I could spell, I'd be there faster. Optics. Here we go. But on the flat Earth, we have a firmament. We don't know what the sun is. We don't know. There's a lot of things we don't know. So check this out. So I divided my room in half with a hanging sheet. I got this light here. It actually has a square lens on it, but it looks round for some reason. Yeah. It's 10 feet on the other side of it. Okay.
Yeah.
My wife's off to the left of me. I'm over here. I said, "Where do you see the sun?" And she goes, "I see it."
Yeah.
She's
Perspective.
pointing.
Yeah.
I said, "She sees it right there." So if I drew a
Yeah.
little circle, on the sheet, she sees it over there at the same time as I see it right there.
Yeah. Yeah.
We're
Yeah.
seeing the same thing in two different positions.
Yeah. Yeah.
That's how we see the sun.
Yeah, no, and I think flat earthers do a good job of that kind of stuff, like showing how much can be perspective. Like this is kind of where I'm at, right? Like I've seen like the globe model as a model, right? If you use it, okay, it will accurately predict to the minute forever the sun rises and sun sets across the entire planet.
Impossible in a heliocentric model. Impossible.
I don't
The
know. Just hear me
three-body
out.
problem,
Just hear me
you're
out.
wrong.
I know.
Yeah.
Just let me finish.
Okay.
Like
Yeah,
I've seen it, right? I've looked into this, right? And you see, I am very open to flat Earth, right? And I'm not debunking it. I'm just saying I've seen it. The actual model, right? If you like model that, it will predict to the minute based off where the sun is. It'll show what the time is in the world. And I've never seen a flat earther do that. That like based off the world being flat, it'll be at 1:11 p.m. It'll be this and then that. And as well with the winter, the globe model will accurately predict summers and winters, right? Having said that, I think it could also be a flat Earth model as well works. But the models I've never seen a flat earther be like even your model, dude. Like you'll have the sun and the moon, and they're going around the same time, and then all of a sudden, the moon just arbitrarily goes in front, and then they're like, oh no, the sun will be on the outer ridge of the Earth during winters, and then move back into a more tighter orbit.
We can prove that. We can actually prove that. We're talking about the analemma a moment ago.
Yeah.
And the reason that is because if the sun circled here, let me go back here. If the sun circled around the Tropic of Cancer, which is the inner yellow line,
Yeah.
right? The inner yellow line right here, then in December it would have to go faster because it's a bigger circle.
Yeah.
It would have to go faster, right? It would have to go faster. Do you agree?
Yeah.
So it has to speed up and slow down. That's
Yeah.
why the analemma is small and big. Now, here's something.
But have you predicted that? Go ahead.
Go ahead, ask me a question, then I'll answer.
No, like that's what I'm saying. So I see these models, and it could explain in a broad sense, but I'm talking like to the minute, right? Like, does that model to the minute predict accurately all sunrises and sunsets globally year round?
Absolutely, 100%. Look, it's a clock. The sun is a clock over a flat Earth.
Yeah.
It is the minute hand. It is the second hand. It is what time is based off of. Time is based off of the flat Earth sky clock. Without the sky clock, there is no time. So you're just backwards. You can take this, wrap it around a sphere, and put coordinate system on it.
Yeah.
Why do we have X and Y? Why do we have longitude and latitude? Where the hell is the Z-axis? Right? If you're navigating on a globe, where's the Z-axis?
Yeah.
If you're navigating a flat Earth, X and Y is all you need.
Yeah. No, I hear you, man. Yeah. So, like, I looked into the Dave Farina. I know you guys had mega beef, but he's done a few videos showing basically
watching him.
This is my point. I think a lot of what we see, I think it could be a ball or flat, and you could explain the same phenomenon.
So here's the thing. There's three baskets.
Do you see what I'm saying?
It works on a flat Earth and a globe Earth. Lots of things go in there.
Yeah.
Navigate west.
Yeah.
Work on a flat Earth and a globe Earth. It works only on a flat Earth. Lots of things go there. We see too far.
Yeah.
Right? The stars never cross each other. Polaris was in through the hole in the Georgia Guidestones, right? Right? And then it only works on a globe Earth. Guess what? Nothing ever goes into that third basket. Isn't that weird?
Yeah.
Right. So wait. Let's go back to time zones for a minute. We're talking about time zones, right?
Yeah.
So, how do time zones work? Right. How do time zones? Time zones are 24 lines from the North Pole to the South Pole.
Yeah.
Just like that, right? It's like sections of an arc.
Yeah.
And then as the Earth spins, the sun goes through. Wherever the sun is, it's noon. And then 1 o'clock, 2 o'clock, 3 o'clock, all the way around. Makes perfect sense.
Yeah.
Right. All right. How many time zones are here at the equator, all the way around?
I don't know. The same, right? Like 12?
Well, what's the number? What's the number? Well, no, times AM, PM. Come on.
Oh,
How many
12.
times? How many? There's 24 hours in a day.
Yeah, so 12.
24.
Yeah. Oh, I thought you meant just the side that's facing the sun.
No,
You mean
no,
all?
no,
Okay.
no. No problem. Yeah.
Yeah.
So there's 24 time zones, right?
Yeah. Yeah.
24 time zones. How about down here? How many time zones are there?
Same. Yeah.
Yeah, makes sense. Makes
Yeah.
perfect sense, right? So the question I have for you: if the Earth was flat, those time zones are going to get wider and wider as you go south, right?
Yeah.
And on a globe Earth, they're narrow here, they get wider, and then they get narrower again, right? You could
Mm-hmm.
literally stand exactly on the South Pole or on the North Pole,
Yeah.
and you can put your foot in each time zone without ever moving,
Yeah.
right?
Yeah.
Theoretically, right? But if the Earth was flat, you would have the same. It would be the same in the north, but once you get past the equator, it wouldn't start shrinking. It would still keep expanding. Follow me.
Mm-hmm.
You have to think. Follow me.
Yeah.
So that we'd have to explain extra time zones, right? How many time zones are there?
And Antarctica? Well,
No, anywhere. Everywhere
yeah,
on Earth.
24.
How many time
24.
zones? 24.
Yeah.
That's what a ball requires. Don't you agree?
Yeah.
Okay. There's 19 time zones in the north, 24 in the tropics, and 32 in the south.
Oh, I didn't know that.
Do you remember they taught you that in school?
No, they never told me that.
You don't remember that because they never taught you that in school. Look it up.
That's
32 in the south, 19 in the middle, 24, 20, 19 in the north, 24 in the middle.
Oh, and so, okay, so you're saying based off if it's flat, the 32 is because it's moving way faster on the outside.
32 is, no, the 32 is because it's more space.
Yeah, yeah,
so
yeah.
There's more time zones. But when you wrap it around a ball,
Yeah.
they cut out. Like if you have a big disc, a big circle of paper, and you want to wrap it around a basketball, the top's going to go pretty smooth. And once you get it past halfway, it's going to get really crumply. It's going to get you're going to have big flaps of paper.
Yeah.
So you have to cut off those flaps of paper to make it smooth, right?
Yeah.
There's big swaths of Southern Ocean that are off limits. They're off GPS. Nobody goes there.
Yeah.
Maybe other continents there.
Yeah,
We don't know.
I want to get into that. Yeah, no, I hear you. Like, don't get again. I think their model is wrong. I think they're lying to us. You know, like the whole vacuums in space to me is just like there's no way that that's possible.
You made the comment that the flat Earth model cannot predict time perfectly, when in fact time is based off of the flat Earth model, not the globe model.